Hi, in a previous video we took a look at the teardown of this Schaffner NSG200 and NSG222A interference mains interference simulator. It's a very cool and interesting bit of kit, so I'll link it in down below if you haven't seen it. Anyway, we thought that there was a failure in the transformer over here, but well, let's take a closer look. Now, of course, when I plugged this thing in, it took some time, but it eventually, while I was trying to use it, released the magic smoke. And I thought it was coming around this back area here, because the top part of it just has all grills on it like this. So the smoke was sort of coming out of this back region. So when I opened it up and I saw this down here, I thought, aha, that looks like the culprit, this huge common mode choke on here. And you can see it does actually look as if like something like has burnt and then melted and dripped down and something like that. But as I remarked in that video, because this is just a common mode choke, I found it really hard to think of the mechanism that would actually cause it to do that, because it's not like, a transformer or anything. If one turn just shorts to another, it's not really a big deal. And anyway, so I didn't really investigate it any further. So it seemed like that was the culprit, but as it turns out, one of my viewers actually worked or is still working at a transformer manufacturing company. He said, no, this is actually quite common. It just looks like the residue from the Polly put the kettle on coating that they actually apply to this thing, and it's no big deal. That is not a burn mark at all. And upon closer inspection, I'm pretty darn sure he's right, because look, it looks like it's sort of like dripped out of there like that. So yeah, I don't reckon, I now am pretty confident also that this is not the burn mark. So let's go have a look elsewhere. Now, as many people in the comments spotted, these RIFA capacitors, RIFA is a brand of these safety capacitors, filter capacitors that go down to mains earth, X-class and Y-class caps. And these are actually notorious for failing after a long time, because what happens is the plastic casing on these things actually cracks and moisture gets into them, and then if you've got these things like sitting around in storage for 10 or 20 years and then you try and power them on, bang, the magic smoke escapes and a pretty pungent odor comes out of these things. But usually they're quite, all the ones I've seen are usually quite violent. And here's some photos just pulled off Google images of various RIFA brand. It can happen to other ones, but these RIFA ones are common that use these plastic enclosures. They're practically infamous for doing this after, 20, 30 years, something like that. And I originally looked at these and went, oh no, they look okay at first glance. And we had what looked like a burn mark on the transformer where I thought the smoke was coming out of. But upon closer inspection, these do look a bit dodgy. So I didn't really give those more than a casual glance before, but if we look closer upon second inspection, I think we can see something down in here. It's hard. I'll try and get the lens down, because it's hard to get this board out, by the way. It's like, yeah, it's not easy. But if you have a look down in there, now it seems pretty obvious. I didn't notice this, but you'll notice that big crack in there like that. I didn't see that before. And if you can see it, big crack down there as well. And I can feel that. There we are. There we go. Get the screwdriver in there. So yeah, it pays to look a little bit closer and not get caught up in thinking that you've found the culprit, especially when I couldn't really explain why that common mode choke would have caught on fire and smoked, really. There was just no mechanism for it. So yep, that now seems pretty obvious. So what I'm going to do is get all those caps out of there. And the good thing about these is that they're not actually necessary for the operation of the unit. So I can simply remove them and power the thing back up and at least get it working. I mean, I should actually replace them, and I will, of course. And you should, by the way, if you find any old gear, vintage computers, or any other vintage test gear or anything else that uses these RIFA brand caps or similar looking ones for mains input filtering either directly across the mains or down from active and neutral down to earth, then replace them. It's a real good idea because they might eventually go bangski. Oh, and by the way, if you're getting in there and desoldering like old gear like this, there can be like lots of real crusty old flux residue on there, and it really goes up in smoke, and it's nasty stuff. I've actually been at a job where we actually set off somebody in the lab that liked repairing old gear, and they bought some old gear in once and started working on it. Nope. Fire alarm went off, building evacuated, and yeah, lots of red faces all around. Oops. Yeah, look at that. Lots of it. Woo. I think what they've actually done with this thing is the board actually gets assembled onto the transformer. The transformer dropped in, all the wires are plugged in, and then they screw it down like this. So I've unscrewed the transformer, and it kind of sort of comes out, but there's lots of wires, just like some of them are permanently connected and stuff like that. So if I get the bottom plate on, I can kind of sort of get in there and maybe get the desolder the board off, but geez, it's really quite annoying. Well, yep, that's obvious, isn't it? Look at that. And if that was just sitting on the board, like, that would have been just so obvious that this thing was blowing. But because it was like, tucked away in there and it was harder to see, you can see it's like bulged out and expanded. All of the cases just completely cracked everywhere, like two big splits on the bottom. And yep, the magic smoke has escaped. And all the other ones look real dodgy, brothers, too. Look, you can see the cracks in there. Look at them all. Wow. That's just, yep. Look, straight across. But that's, most of these other ones were impossible to see inside there. And once again, you might probably see maybe the bulge and the cracks. These things are just absolutely hopeless. There's practically 100% failure rate. In fact, there is 100% failure rate on these. Wow. And lucky last. There you go. Yep, all completely dodgy. And these smaller ones are the Y-class caps, and the Y-class caps go from active and or neutral down to earth, whereas this one is an X-class, X-class, half an X-class, and because half the magic smoke has escaped, and the X-class goes directly across the 240 volt or 110 volt mains. So there you go. Yep, classic RIFA capacitor failure. Yep, and it would have been bleedingly obvious if they weren't sort of like hidden away in there, and we didn't have the other red herring that we chased with the transformer. So there you go, easy peasy. So according to the schematic, this one was a 5 microfarad job, and the only X2 I have to hand, brand new, is this 0.1 mic one. And look, it doesn't really matter. 5 microfarads actually is for the 50-60 hertz model. It's actually lower value for the 400 hertz capable thing, and we're only talking about a, basically filter in here. So as I said, this thing will no doubt work without any of these caps installed. They're just suppression filtering caps, basically. So I don't know, I could try this, or maybe I could like steal some from an old board, perhaps, something like this. Here's a bunch of well, they'd be they're X2 class caps, so 470N, there you go, so slightly larger. So maybe I can steal some for them. And these look like Y class caps in here. You can tell because they're actually going to ground here. You can see that they're across there like that. So they're actually going in there to ground. But the part number, unfortunately, is a bit oddball. And these ones are actually a X1 and Y1 class cap, so they're quite nice. Unfortunately, very low in value. 101 there would be 100 or 100 puff. But hey, check out that one. That's a 820 nanofarad Y-class cap. Nice. And of course, once again, because it's Y-class, you see it going over to ground here. So as you can see, it's handy to have like a scrap board like this in your junk bin, because you can, these are still great quality caps. So you can, suck these out and use them if you've got like an old bit of gear that's, all the magic smoke, all the snots escaped from these old RIFA type or other brand, X or Y class caps. Then, yeah, you could, these are perfectly good to use. So as I said, these are X-class capacitors, in this case X2, which is the second highest rating one. X1 is actually the highest, and you can get lower than that, but X2 is by far the most common, and Y2 ones, which we've got, this one just says Y, so I'm not, it's a really old one, so I'm not sure what the deal is there. But anyway, but they are designed for different purposes. As I said, the X-class goes across the mains, and they're designed so that they don't fail short, i.e. they don't catch on fire, because it's directly across the mains. It's got low impedance, lots of energy behind it, so they're designed not to explode. That was the plan anyway. But yeah. These older ones do, unfortunately, degrade over time, but they're supposed to not do that. Whereas your Y-class caps are designed to go from active or neutral down to ground, and they're designed not to have any leakage at all down to ground. So they're designed for different purposes. Now, you can actually use a Y-class cap in the X configuration, but you can't use an X-class cap, or you shouldn't use an X-class cap in a Y-class configuration. It's just a safety thing. You can see some ooze down there on the board. That's just spewed out the bottom of that cap. We'll just clean that off before we put a replacement in. One of the problems with soldering a board in situ like this, when it's vertical like that, is the solder actually, with large like ground planes with no solder mask, the solder actually falls down under its own weight under gravity. So you really have to flip this board up horizontal in order to solder it properly. You've just got a regular, like a tinned copper PCB like this one. Right, so I'm actually fairly confident to turn this back on now, because I'm pretty darn sure that there's nothing wrong with that transformer. We've taken out all the X and Y class caps. I mean, we had 5 for 5 failures there. That's just insane. I don't have any Y-class caps in there, which power these two neons, as well as doing some filtering down to earth. Now, a few people in the comments, quite a few actually, mentioned that possibly this thing could have died because I was like a pulse in this thing without a load, and there's absolutely no way that I can imagine where that would cause a problem, because this big ass filter, that's what this big ass filter and this big ass choke do here. That's the whole point of having these enormous things, so that all the output all the output pulses on here don't affect the input, and not having a load on there shouldn't be an issue whatsoever. So let's just power it on and see what we get. Yep. We're back up and running. Sweet as. There you go. And I've of course seated that chip back in there. So that's maybe why like before it, the magic smoke escaped, I couldn't actually get any pulses on the scope. So I'll hook up the scope again and give it a whirl. Okay, switch the output on. Bingo. There's our sine wave. Beautiful. Let's see if we can get a pulse on it. And of course, as I've mentioned, when you're doing tests like this, high voltage stuff, you need a proper high voltage probe, available on the EEVblog store. Got to plug my merch. A lot of people don't know that I sell this. It's a very nice high voltage probe. Divide by 100, beautiful, and it plugs straight in with the banana jacks. Okay, so I'm going to set it to 100 nanosecond pulse here, just symmetrical, whatever. I'm going to set it to 500 volt pulse, and we're going to single pulse this thing. And we'll set the scope up for a 100-to-1 probe, because that's what our high voltage probe is, and we're at 200 volts per division there. So let's run that. You can see that's actually live. So what we want to do is set our trigger point just above that. There you go. So it's now free running. We'll put it on normal mode. Then we'll single shot capture that. Now if we trigger it, hopefully we'll capture something. That's the plan. Whoa, yep, got one. Something in there. That's how it doesn't look like there's anything in there, but because it's only 100 nanosecond pulse and we're currently at 5 milliseconds per division. Bingo, there it is. Look at that. And that's at 20 nanoseconds per division, 40. So, you know, it's roughly 100 nanosecond pulse, something like that. Let's actually set it for 10 nanoseconds and see if it's faster. So I'll keep the time base like that and single shot capture that again. 10 nanoseconds and single. Bingo. Oh, it's the same. Bueller. Let's try that again. It's the same again. 10 or 100 nanoseconds doesn't seem to make much of a difference. Oh. Anyway, it's working. And if we change the polarity on there, sorry about the glare on the screen. Yeah, I do have like an anti-glare filter. Just haven't put it on yet. It's a great scope, but yeah, the screen glare is terrible. I've changed polarity and let's zoom in. And bingo, there's our pulse. Nice. And I'll double the amplitude. I'll single shot it again. And, oh, there we go. It's a bit problematic. It's just picking a random location on the waveform because I'm just free pressing it here. So I've actually set it to 1 kilovolt pulse this time, and let's single. There we go. That's our 1 kilovolt pulse. It's not that huge, is it? So we're actually working a treat there. This is a winner chicken dinner. So there you have it. As predicted in the previous video, this thing actually works. I didn't think there'd be anything hugely wrong with it. I just think it was just surplus to requirements or whatever. Maybe, you know, it doesn't support the new testing standard they're testing to or whatever, and it's probably been sitting around for a long time, which is why these damn RIFA caps have failed. And these are, you know, like notorious for failing like this. It just like over long term. The modern ones are a lot better, but these older ones just absolutely horrible. They're infamous for doing that. So if you've got any old gear or anything with these, just replace them as a matter of course, even if they haven't failed. Especially if the thing has been like, I believe it's different if you keep them like, you know, powered up 24/7 for like, you know, 15, 20 years or whatever. I believe they actually do have a longer life. But yeah, if you put them in storage and then just try and power them up and they've got moisture in there or whatever, it's like, poof. All the magic smoke's going to escape. In this case, we were 5 for 5. I mean, all of those have failed. They've all got cracks in the case or whatnot. They just look horrible. Look at them. They're just awful. And so that's how bad these things are. 5 for 5. Unbelievable. But it looks like we've got it working. I'll eventually get some Y-class caps to put it back in there and, you know, restore it to its original thing. But it looks like I have roughly working. You know, you could try out all the functionality and everything, but that could take some time. But it seems to be generating the pulses that we want. So that's a very nice mains interference simulator for the lab. Awesome. I can test out products now. Just pulse it in there, see if they fail. Terrific stuff. Anyway, if you like the video, please give it a big thumbs up because that always helps a lot. And you can discuss it down below in the comments or over on the EEVblog forum. Catch you next time.